Okay, so today we are talking about graphs of sine and cosine. We are going to put the fun and periodic functions. You may have noticed we capitalize this here. Okay, so periodic functions are functions that repeat exactly in regular intervals that are called cycles. Okay, and then the length of a cycle is called its period. So these are periodic functions, and then there are non-periodic functions. And then the cycle can begin at any point on the graph, but you will see it keeps repeating that pattern. Okay, so in the first one, they show you, just like we talked about on our packet today, when you are finding a period, you are going from a maximum to a maximum. You can also go from a minimum to a minimum. There are times where you can use the x-intercepts, but a lot of times there are multiple x-intercepts in a cycle, so it's best to use the maximum to the maximum or a minimum to a minimum. And then we're going to compare those to functions that are not periodic. So they don't repeat exactly, because this one, it starts off kind of small and then it gets larger. So what we have to do is determine whether the function is periodic. Okay, so does it repeat itself? And if it is, then we give the period. Okay, so for part A, we can see this is following the same pattern. All right, so we have to calculate what that period is going to be. So a good way to do that is to do max to max or min to min, but we don't have the exact max here. Like the arrow is going there, so it is going to be best for us to use the minimum values. And then we can just find the distance between them. So this looks like it's at 3. This one is at 9. So we can just subtract. 9 minus 3 is going to be 6. So we're going to say yes, and P is equal to 6. Okay, so the capital P is what we use for the period. Okay, now this one keeps going up, but when something repeats itself, you're going to see it go this way again. So this doesn't even happen again. So this would be an example of something that is not periodic. There's one more on this page that's not periodic. Can you guys find it and write down which one is not periodic? Which one does not repeat? Okay, so which one do you think? What's the other one that's not periodic? D. D is correct. Okay, all the other ones are going to repeat. So this one here. I guess maybe if we could see more of the pattern, but if it's periodic, they're not going to have like these open circles here. You have open circles here. This is actually called a step function because it's like you're going up the stairs. Okay, for C, that one does repeat. That one's a little bit harder to do, but you can see that you have like this stretched out M shape, right? You have the M, the M, the M there. Okay, so again, like we did before, sometimes it's best to do the minimum to the minimum. Okay, now we're gonna start to use some strategies. We see this is pi. This is halfway. So if this is pi and this is halfway, what do we call this? Pi over 2. Do you guys know what we'd call this one after pi? 3 pi over 2, because it's 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, so if it goes from pi over 2 to 3 pi over 2, if we subtract, 3 pi over 2 minus pi over 2 is what? It's pi, right? 2 pi over 2 is pi? Yay! Okay, so our answer is yes, and our period is pi. Okay, so I want you to try to find the period for part E. All right, so again, a strategy should be either go max to max or min to min. Okay, it doesn't matter which one you do. Okay, so if I go max to max, what is this? What radians? Pi over 2. This sets what we're counting by. So remember when I taught you the unit circle, we were counting. So this is 1 pi over 2, 2 pi over 2. This one will be 3 pi over 2. What's the last one where this ends? This one will be, yep, because this is 4 pi over 2, so this one's 5 pi over 2. So if I need to find what the distance is, I just subtract. Okay, and then you can reduce. So 5 pi minus pi, you have 4 pi over 2, and what does that reduce to? 2 pi. Okay, so this is yes, and the period is 2 pi. Okay, now when we graph trig functions, we're going to be graphing without a calculator. So when we're doing that, you probably noticed in your packet today, we were working with some pretty simple numbers, right? We had a lot of ones, a lot of zeros, okay? But they all related to your unit circle. So really, you can use any place on the unit circle to help create those points, okay? So the trig functions that we studied before, the sine, the cosine, even the tangent, those are periodic, and you can graph the sine function by using your y-coordinates from the unit circle, which is what you guys did today. And then we know that we can use f of x equals the cosine of x by using our x-coordinates from the points on the unit circle. Okay, sometimes instead of like the x input, you might see theta. Okay, your x is the theta. Okay, that's your angle in the standard position. And when you are looking at this table that they provide for you, okay, look at some of these values in here. Okay, do we really want to graph root 3 over 2? No, okay, that's going to be a decimal. That's not going to be as easy to do, but you could graph that point. So they're showing you that at pi over 3 here, you would get root 3 over 2. At 5 pi over 6, you would get 1/2. Okay, at 4 pi over 3, you'd be at negative root 3 over 2. They're showing you those points. And then at 11 pi over 6, okay, that you would have negative 1/2. So what they're saying is, hey, these are the theta values. This is the y-coordinate. That is how it relates to the unit circle. What we're going to focus on are the values that we did today in that packet. So the values that we focused on for our theta value, do you guys remember the first one that we did? 0. Okay, which is here. The reason why we chose 0 is because the point 1, 0, okay, is going to give you 0 for the sine of x. And you guys did really well with this. If you ever have trouble like thinking about what it is, remember that in a table, you're just plugging in the values. So when you're plugging in theta, the sine of 0 is equal to 0. When you plug in pi over 2, the point is 0, 1. So at pi over 2, what you guys did is you were plugging in pi over 2 as the radian value, and your output is the y-coordinate. Okay, and then we did pi, 3 pi over 2, and 2 pi. So we're going to be using these a lot. Okay, at pi, you have -1, 0. So when you calculate the sine of pi, all you're doing is putting that y coordinate. At 3 pi over 2, you are finding that y coordinate, okay, which is -1. And then at 2 pi, that y coordinate is 0. When we graph these, we're going to graph them in a certain pattern, okay, in a certain way. The first thing we're going to graph is 0. Okay, so at 0, you are at 0. That's the first thing you're going to graph. Now, did you guys notice that at the start and at the end, you're at the same place? Okay, because that's going to be the period. So if the period is 2 pi, which is what you guys found it is, that's where it's going to repeat itself. Okay, x-intercepts occur multiple times in this one. So halfway, you're also at 0. So the first thing we're going to do when we have a sine function is we're going to start at 0. We're going to end at the period, which this is 2 pi. And then halfway, we're going to put the other x-intercept. And then look what happens in between these 2 points. In between these 2 points, it reaches the maximum value, 1. And then in between the next 2 points, it reaches what value? The minimum, which is -1. Okay, so in this graph, you have the x-intercept, you have the max, you have the min, and then you have the x-intercept. Okay, so when we graph it, we have this series of points that's going to continue, and then we graph that with a curve. Okay, you guys probably recall from the packet that the amplitude is found by doing half the difference between the maximum and the minimum values of the function. And one thing you should know about the amplitude is it's always going to be a positive value. Okay, so when you do the difference, okay, you will get a positive value. And then when you multiply it by a half, therefore it will be positive. So in your packet today, you did 1 minus -1 to get 2. 2 times a half was 1, okay? And our amplitude was 1 for the original function. And that's going to change a little bit. Okay, so for your characteristics chart, there's a few things I want you to notice. So one thing on here is these are for the graphs of sine and cosine, the parent functions, which is what you did today. Tomorrow, we're going to start to do transformations of those functions. So when you are graphing the sine function, just like we showed above, the sine function, we're going to focus on these 5 points here. So we're going to focus on, you have the x-intercept, the max, the x-intercept, the min, and then the x-intercept. When we graph the cosine, that's a little bit different. If you actually shifted this over, they would be the same, but your cosine starts at 1 and ends at 1. So it starts at the max and ends at the max. Halfway in between is the minimum. And then halfway in between the max and the min is going to be the intercept. Okay, and we'll talk more about that pattern tomorrow. But here you start at 0, you go max, min, 0. Here you start at max, x-intercept, min, x-intercept, max. Okay, your domain is all real numbers, so you can plug in any value. Your range is -1 to 1, okay, because 1 is your max, -1 is your min. And then what you found today is the period for each one was 2 pi. Okay, and your amplitude for each one was 1. Well, for the original. And you guys saw some today where the amplitude was different than 1. Okay, and then we're going to save the patterns for tomorrow for when we graph.